How you doing? Sean Tech here, back again. So one of the last electronic circuits videos that we did, we were working on a 555 timer chip that we actually soldered down to one of the boards in this spot right there. Ugh. It's all messy looking, is what it looks like. Actually, what this is residual fluxing agent, is what this is. Generally speaking, for a circuit, any kind of circuit, it's unwanted. It can cause a variety of damages, and generally you don't want to get rid of it. Now, normally speaking, there are a variety of substances that gets rid of it. Everything from your it depends on the type of fluxing agent that you're using to it, but it can be anything from like your standard rubbing alcohol to soapy water or water with a surfactant added into it. But ultimately, you can kind of get rid of it with just about anything out there that the fluxing agent people kind of tell you that you can do. I'm actually using kind of a combination of some rubbing alcohol because this stuff, actually, if you leave this stuff on here for a little bit too long, it does become kind of difficult to remove. As actually you can probably tell, there is a little bit of a darkening of my Q-tip that I'm rubbing across here, and I can actually still see some of it still sort of spreading around around the chip. So it's nothing that's going to cause an immediate damage to it. But it's usually something that you want to get rid of as fast as possible once you are done actually doing the solder job on your actual circuit, is what you want to do with it. So that's looking a little bit better. We'll let that kind of dry out for a little bit there. One of the folks that was in the comments actually commented on saying like, hey, this was a nice reminder that surface mount versus through hole. Now, through hole is the other kind of component that generally, if you were to talk to most people who do manufacturing, there's a good thing and a bad thing about through hole. And let me kind of demonstrate this to you. I actually have some bar stock, a very small bar stock of my last 555 timer chip that I actually have in my inventory right now. I might have one or two other ones somewhere out there, but the 555 timer, if we were to consider, there's the surface mount version of it right there, and coming along here is the through hole version. Excuse me, sorry. Hi, I'm huge in comparison. That's one of the nice things that people like about through hole, is that for plug and play type devices, if you were to consider the direct comparison between the two circuit chips, one of them is much larger than the other one, and so one of them's a little bit more finger playable, if that makes any sense. Like, it's able to be picked up and handled just a little bit more when in comparison to another size chip. I mean, in for instance, like I'm holding this right now with a pair of tweezers. Let me try to get in a nice spot there, and it's pretty large in its overall size. But if I were to take, say, a surface mount 555 timer like what I've got in my hand right now, it's considerably smaller overall compared to it. And this, believe it or not, like, this is what we would call the small outline package, or the small outline integrated circuit, SOIC or SOP, whereas the through hole is what we call a dual inline package, a DIP. Is what that is. Now, the DIP package, dual inline, is because on the inside of it, on either side of the chip, you've got some legs kind of sticking out with it on there. And these are the through-hole legs that actually have to go through the board. You need a specific type of chip slot on your board to be able to do this with. My board has a chip slot U1, which I'm going to kind of put on here right now. Notice, for instance, that we have some polarity indication on the chip. Well, on the silk screen layer of the circuit board, on the silk screen, I've got a little bit of a notch that's up here on the top part of it that indicates kind of where the top part of the chip is. But then the square actually indicates pin 1 of the chip, and very similar to surface mount components. Not to say that I'm a full-on expert or anything like that, but at the same time, what I've seen over the past couple decades worth of engineering is that pin 1, notice the notch up on the top of the chip there? See the notch? See the notch there? See the little notch? You see the notch? And there's a notch over there. Yeah. It's almost like they put that there for a reason. so pin 1 happens to be the top part of the chip here. And then it goes counterclockwise or anti-clockwise for you one sole British viewer that I think I have right now. I have one person from UK. Thank you for tuning on in, and thank you for all you folks for coming on in and taking me out. It makes me feel great knowing that this is like both entertaining, well, educational and entertaining, or one or the other, or both. Who, leave it. Let me know. Let me know in the videos below, which or in the comments below, which one you think it is more. Pin 1, 2, 3, 4, 5, 6, 7, and 8. Now, the nice thing is about the through-hole component is that it can go through. These are holes. These are holes. These are what we call plated through holes that are in the circuit board. Now, I'm going to try to zoom in on one of these plated through holes. And I'm probably going to have to do some light magic in order to get this to kind of show up here. The inside wall of that hole is actually plated with a small amount of electrically conducting material. And so here, let me turn that up a little bit there. Let me turn that up a little bit more. This might start to get a little bit hazy sometime soon. You see that there? See that? So the inside of that hole actually has metal on the inside of it. All the holes actually do. So I'm going to go down to the next hole, and that has metal on the inside. And that's because through holes are typically they're supposed to be, in a majority of cases that I've seen. Again, I'm no expert or anything like that, so it could be a variety of different things. But they are supposed to be plated so that the top of the board, what you're looking at right now, is like the top flat layer of the board, is actually going to be electrically connected to a hole on the bottom side of the board. That there's actually an electrical connection. So, like looking at, for instance, this track that is on here. There is a track underneath here, and I'm going to kind of move this over just a little bit. So there is a electrical pathway coming from somewhere underneath this hole down to pin number 2 of this that connects over to this hole, onto that hole, and then after the connection has been made, it will actually, if I flip this over, you will notice that there are some holes on the opposite side of the board that link up to this, including a square hole, not a square hole, but a hole with a square pad around it that is connected up to that part of it there, and that the insides of these holes are also electroplated with material on the inside. This actually has to do with the very interesting way, at least in my opinion, very interesting way that boards get manufactured, where the hole actually gets drilled, and through an electrochemical process, the inside of the holes actually get materials deposited onto it, while the printed circuit board is actually submerged in a material that has a metallic compound mixed into it. It's an interesting subject, which we can talk about a little bit later on. But the cool thing is about what so many people do like about through-hole electronics is that they are big and able to be easily handled. For instance, I am handling this right now with my hand. You might see every once in a while a wire that is attached to my wrist. I am not wearing the latest smartwatch, nor am I charging my watch right now as it's connected into the wall. I am wearing what's called an electrostatic dissipative wrist strap, an ESD wrist strap. It helps if any static builds up on me, like static, like the kind of static that when you go across the floor and you zap the doorknob, or the doorknob zaps you, or whatever way it happens to work. This basically prevents any static shock that may build up onto you, so that it goes down through the wire and into earth ground rather than go into the chip that I am holding into my hand, which may potentially break it, and we don't want that to happen. We'll talk a little bit more about ESD going forward, but that's why I'm kind of wearing this on there, more for just the emphasis being able to do it. So I'm going to take this chip and place this onto the board so that the notches are aligned up to it, as they are kind of right there. What I'm actually going to do is I'm going to push this electronic chip through the holes on the board. This is kind of tough to show on the screen here, but there the pins are actually all the way down and going through the board and all the way down onto the bottom side of the board. You can actually see that the pins are actually connected all the way through. So now the thing that people like about through-hole chip components like this is that they're big and easy to handle. The thing that people don't like about these chips, these through-hole components when compared to surface mount components, is that they are big and actually difficult to manufacture with in comparison. Like in terms of a machine being able to put them down, they are much more harder to work with. But for hobbyist type of folks, these are actually kind of a nice thing. So a variety of electronic manufacturers are out there, and they're trying very desperately hard to get rid of through-hole as much as possible in the higher volume manufacturing side. But there's still a large number of companies that I personally know of that still work with through-hole based components. Let's solder the pins into place and go over an important soldering concept in comparison to it. The soldering concept for through-hole should follow that you need to place the soldering iron in contact with the pin and the pad. You want the solder to flow over the pin and the pad. Now the nice thing is about this in comparison to surface mount is I don't have to tack one of the pads down with any amount of solder to it on there. I am going to apply a little bit of some fluxing agent. You typically don't really have to do this for surface or for through-hole based devices. There's already kind of some flux inside of the solder as it is, so you really don't have to necessarily do this on there. One thing that you typically have to do is increase the amount of temperature or the amount of time that you are holding the soldering iron, which I've got in my hand right now, set to 650 degrees Fahrenheit with a bent tip, with a T15 bent tip. Hako station, and you have to increase the amount of time that you hold the soldering iron down to the actual pin itself. Now, one of the things I'm going to do before I get started with this, I'm actually going to grab a helping hand, which got my original one from Radio Shack from way back in the day. I'm going to grab my helping hand, which just has a couple of alligator clips that's on it. That's going to help me kind of hold the board into place. One of the harder things to do with through-hole based components is the fact that the board has to be somewhat mounted in some ways that it's sort of held into place. So I'm going to try to do this as best as I can. Let me get the pins on the screen here. There you go. Change the focus up just a little bit there. All set. Okay, so what I'm going to do is, rather than surface mount where I really don't have to touch the soldering iron to the pad for that long a time, in through-hole you actually kind of do. And what you want to see in this is once I put this down, the fluxing agent is going to start to activate, and the pin is going to start to get kind of hot. I want the solder to touch and melt on the actual pin itself. You see that there? I want a sort of an upside down volcano really a volcano to kind of form with it on there. And I believe there's some other things that some of the various solder people will say, like you want it to fill down and into the hole just a little bit there. I know a lot of people do things a little bit differently to it. Let me try and demonstrate this a little bit more up close and onto that pin. It's hard for me with my working distance to focus on either the pin or the pad at one time here, but I'm going to try to kind of do my best to that here. Actually, let me also try and increase up the exposure just a little bit because I've zoomed in just a little bit here. That should make things a little bit easier to see. So with my soldering iron with my tin soldering iron here, I'm going to heat this up and apply the lead-based solder over to the other side here and see how easy that is to kind of form to it on here. I am touching it to the pin. I am actually touching the solder to the pin itself, not the pad, not the pad. It will go down to the pad if it's all being done correctly, but you want the pin to be hot enough. You want the pin to have enough heat so that the solder fuses down and into the actual pin itself. It will naturally be attracted to the pad once it gets down to it, and in many ways I'm still kind of resting the soldering iron on the actual pad itself. So part of the pad actually has the soldering iron still attached to it. Those are the first four. So now we're going to move on to the other four. And there's the first two. So I'm going to actually apply some fluxing agent down to all of these. And normally you don't have to apply fluxing agent for through-hole. The the solder wire typically has a core on the inside of it that already has some of the fluxing agent in there. But fluxing agent helps soldering. That's the end-all, be-all for how soldering kind of works with it. So we'll apply some of it here. Another one we'll apply some right over here. Okay, you see how that there's a very nice. I'm going to try for some of these last few of them to kind of get as much of an angle as my microscope will possibly allow me to get here, given the working distance that I have. And I might actually just take this thing out and just sort of, yeah, let me take it out of the mount for a second here. And then let's focus up on what the actual pins what they actually kind of look like here. And there's some holes there. Where are you? Hello, pins. Hi. Are you there? Hello? 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 Are you receiving me here? That's VCC. Oh, gosh, I'm way over in the wrong spot. There I am. There I am. Why is my light source pointed all the way over there? All right, so why did my light source just fall over? Oh, gosh, my lamp's falling apart. Oh, no. Jeez. Hello. Hi. Can I see you? Is that okay? Can we look at you? Can the audience please see what you look like here, Mr. Pin? Hey there, Mr. Pin. How's it going? So you see kind of what these look like there? Like they look like there's a little bit of a volcano down at the bottom of them where it's like kind of creeping up the pin. And what actually winds up happening a little bit later on is that these pins will be clipped at some point if you're doing it kind of over by hand here. Now I'm actually going to try my best right now to kind of show what this looks like on its side here by taking my helping hand, taking my solderers. People who do soldering always say, like, I really wish I had a third, fourth, fifth, seventh hand for being able to do what it is that we do on here. But that's why we have our helping hand is what we have. So I'm going to come on in here with my soldering iron, which has a pin that's already kind of fluxed to it, and I'm going to hold this down to it. And you see that? You see what that kind of looks like? And it fills in on the inside the hole right there quite nicely. I'm going to come into the side angle here and touch the solder down to that. You see what that looks like? A nice fillet. It's got a nice like little volcano fillet is what that kind of looks like. It's got a nice way that it kind of creeps up the side of the pin. Then we just come in with a pair of snips and we carefully snip the wire off at this point. Normally you don't want to solder with too much of a wire coming out of it, and we'll explain why maybe in another video, because that's actually kind of a longer discussion in terms of what that is, and we might be able to do a little bit better of a demonstration. But yeah, afterwards what we'll do later on is we'll snip these kind of guys off, making sure that we don't snip the fillet. We don't snip the solder, we just snip the pin by itself. So anyway, that's how we do through-hole soldering for a 555 timer on a circuit board. If you're interested in seeing anything in particular, try to get worked on, let me know in the comments below, something we can discuss, something I might have around in my house or in my laboratory, and whatever I go, whatever I'm going to call that. I've got this here. I call it my laboratory, because it is. It basically is. It's a small extension of what I normally have over at the college where I normally teach. So let me know in the comments below if you like it, if you don't like it, if you're looking to see something else with it on there, and I will see you around the next time. See you later.